there's a room right here with the crusher, and you pass coarse ore through the crusher to a lower bin that accumulates ore that's down to 3/4 inch minus, which is ready for the mill. This is the feeding device. It's a conveyor that brings the ore out very slow, 1 ton an hour, and feeds it into the mill, which is this cylinder. The mill is turning at a very critical angular velocity. It's half full of balls, and down here you can see similar size balls that are on display. Different size so that most of the ball area is filled up with balls. As the mill rotates, these balls don't quite centrifuge. They come up to the top and then cascade down on the ore passing through the mill. And that cascading action gives a great grinding capability of the ore. And the idea is that the ore coming in the mill should go through very quickly. And in the process of doing that, it doesn't get adequately ground. What you're after is a thing called liberation point, which is that point at which the individual particles of gold in the rock are free. Once they're free, you got a shot at recovering them. But you don't want to overgrind. You create lots of problems, and it's expensive. So you come out of the mill as a screen that takes some of the very coarse material, sends it into this trough, which is called a classifier. Everything fine enough to go through that little trommel screen goes over a series of amalgamated plates. These are plates that have mercury on them. The plates are 1 foot by 2 foot, slabs of copper, 1/8 of an inch thick. They have been electrolytically coated on one surface with silver. And over here we have a dressing room where the millman would put a thin veneer of mercury on the plates. There were 6 of them overlapping each other in this trough. All of the ore, now the ore entering the mill, water is added at the front end, and also a little bit of mercury. So the grinding is a slurry process. Coming out of the mill, this slurry then is what's passing over the plates, and it goes down into the classifier. Meanwhile, the classifier, this particular one, is a raking mechanism. And the rake goes down and then scoops along the bottom of the trough and then raises up and goes and repeats this process, so that anything that's heavy enough to settle in the little pond at the bottom of the classifier, if it's heavy enough to settle, it needs to be reground. So it would go back up and be washed down into the intake of the mill and go through the mill again. At any given moment, when the mill is up and running, you have a ton coming in, you have a ton leaving the classifier as a slurry that the material is ground fine enough that it's suspended and will go over the discharge. So that's a ton leaving, and you'll have about 5 tons going around and around in a circle in the process of being ground. The primary recovery for this particular mill was the mercury process. The millman would check the plates. When the plate became, in his opinion, heavily burdened with gold as amalgam, he would take a plate out at a time, go into the dressing rooms with a hard rubber squeegee, take all of the amalgam off the plate, redress the plate with new mercury, and then put it back in. He would do this repeatedly to each one of the plates. Depending on how rich the ore was, he would have to do that every half hour, every hour, something like that. What didn't get caught on the amalgam plates, you have a second shot at with flotation cells down here. This is a bench scale flotation cell right here. And it looks like a mixer, an oversized mixer in a kitchen. And the impeller At the bottom is intended to make bubbles. The shaft is hollow. The impeller spinning draws air down into the mass of ore that is slurry. And then two chemicals are, in this case, the testing bench scale. You try different reagents to see what would work best for your ore. But always one reagent made a bubble, and the other reagent made a surface tension phenomenon that collected all of the metallic elements on the bubble. So when this was done right, why the ore would yield all of the mineral as a froth, which would then flow out of the container. Bench scale there, this is the full scale where you have these big cells doing exactly the same thing. You're feeding two chemicals in, just drips at a time, sufficient anyway that all the metallic, everything metallic gets taken out of the ore. A lot of the gold gets included in other minerals, like the iron sulfide minerals and so on. Will contain a little bit of gold, and the only way you can get that out is through a very expensive smelting process. So in the early day when the mill was running, why you'd accumulate all of these metallic particles. You would put them in bags, dry the bags so you're not transporting any moisture, and then you would send them off to the smelter that was located down in Tacoma, Washington. They always liked to get ore from the mines in the Willow Creek district because they were high silica content, and smelters really need a lot of silica in their process. So that was the whole process then. One man was adequate to run the mill. The mill